Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from lunchboxsessions.com. Today we're going to have a look at how to interpret a hydraulic schematic that has several different types of pressure valves in it. Pressure valves are usually drawn in the single square type of symbol and often show only one poppet and one spring, and sometimes that means it's simply a simplified symbol where inside there may in fact be two poppets and two springs, but the simplified symbols are more common. And in this particular circuit, we're covering three types of pressure valves. There's a system relief valve, usually right close to the outlet of the pump. There's one pressure reducing valve. Remember, that's the valve that is usually drawn already in the open position with the pilot on the downstream side. It's used to reduce pressure on the downstream. And then there are two sequence valves. And sequence valves, the symbol is drawn almost exactly like the relief valve, except that you know it's a sequence valve because its outlet is not headed back to tank. Otherwise, it is mostly drawn the same as a relief valve. It's drawn as normally blocking or normally closed. Many types of pressure valves will often have a third line that is the pilot spring drain, a very important function. Pressure reducing valves may have them, sequence valves as well, and so that's a third line. And of course, sequence valves, since they are a normally closed type of valve, primarily meant only to allow flow to pass through in one direction, normally require a bypass check valve as well for the opposite direction of flow. Let's get this circuit rolling and let's start to analyze the layout of the schematic and the function of the machine. So notice, of course, that we've got a fixed displacement pump, so the system relief valve is very important, but that the system relief valve is not currently in use. With the directional valves in the neutral position, we find out that the left circuit valve, the directional valve on the left side here, is a tandem center, or sometimes known as P to T connected, and is simply taking our pump's flow back to tank unloaded, keeping our pressure at a minimum level. Over on the right-hand side, the directional valve is a closed center valve with the P, T, and A and B work ports blocked when the valve is at neutral. Let's bring up our controls and let's take the circuit through its paces and watch what happens. Notice that while both directional valves have been activated for P to A flow, only the clamp cylinder is currently moving. And only when the clamp cylinder gets to the end of stroke does pressure build and allow the drill cylinder to extend. Now perhaps that's going to be a lot easier to understand if we bring up a feature that we call the mimic. So the mimic shows our two cylinders. There's our drill currently retracting, and here comes our clamp retracting back to the start position. So that gives us a bit of an understanding of what the machine is doing in the factory setting. And let's just say that these blocks are perhaps a rubber block that is being drilled after they're clamped into position. So let's watch the system operate once again as we ask both cylinders to extend, but only one cylinder does extend. Only the clamp cylinder is extending, and that is because there is a sequence valve on the drill circuit that is preventing the drill cylinder from extending until enough pressure builds on the clamp circuit, and that back pressure becomes present and pops open the sequence valve, allowing the drill to extend. So that's a simple way for us to get one thing to happen before another in a simple machinery circuit. And notice that while the drill is retracting, that the return flow bypass check valve is allowing bypass flow. So let's analyze while extending once again. Notice that it's important that we don't squeeze the rubber block too hard. We only want to clamp it tightly. And so in order to prevent over clamping, notice the pressure reducing valve becomes active in reducing downstream pressure once the block is in the clamp. The pressure reducing valve is now active, keeping our clamp from squeezing too hard on the workpiece, but back pressure does build and allows the sequence valve on the right-hand half of the circuit to open, which allowed our drill to extend. Returning the valves to neutral, we find out that the system cools down, the pump's flow is unloaded back to tank. But now let's operate both directional valves in the retract position. We're going to ask both cylinders to retract at the same time. What do you believe will happen? That's correct. Only one cylinder moves. The drill cylinder has to be retracted first, and that's due to the sequence valve on the clamp that is waiting for pressure to build up from the dead-headed drill cylinder, and once that pressure builds up, the sequence valve for the clamp retract can go through its paces and retract the clamp. That's a simple explanation of how sequence valves are used in a circuit, together with a pressure reducing valve and the relief valve. The relief valve, of course, you noticed only became active when cylinders were deadheaded, when no motion was possible on the cylinders, and yet directional valves had been operated asking for cylinder motion. The deadheaded cylinders basically meant no flow path for the pump's flow other than through the system relief valve. We've gone through a brief interpretation of a schematic that has a number of different types of pressure valves. Hopefully that's helpful. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.